Okay, thanks everyone for coming. How's it going so far? Good? Good. I had a lot of drinks last night. I wasn't ready for that. So I had a slow morning this morning. Anyway, thanks for coming. So my name is Tal. I'm Senior Director at Contrast Security, and I'm going to talk to you about serverless security. Serverless Top 10 is a project of OWASP. But this talk is not just about the project itself. It's about serverless security in general as well. So we'll understand why we actually need this project. Okay, so who am I? Why am I doing this talk? So about 4 years ago, I joined Protego, was a serverless security startup. We did serverless runtime protection. The company was acquired by Checkpoint. And then I started my own company called Cloud Essence, where we did serverless security testing. And we got acquired by Contrast. And I'm there working in Contrast since. So I've been doing serverless and serverless security for the past about 5 years. This is my main topic in the last 5 years. And this is why I'm here to talk to you about. Because not everyone understands why it needs, why is it a new security topic? Why is it not just cloud security or app security by itself? And everything that applies to cloud or to application security applies to serverless automatically. So in some ways, yes and no, and we'll try to understand why. First thing, let's understand what is the difference in serverless. If you heard microservices, like everyone uses microservices. So what is serverless? How is it different? So of course, it's not a monolith application, but it's not even a microservices where you have still have some boxes that contains some parts of your application, but instead it's really just resources. A lot of resources, they are not really connected to each other. They are not in the same environment. The only way that makes them connected in some way is some configurations that you made, whether they are API calls, but they can also be other cloud events. And we'll talk about that later. Cycles, of course, not waterfall, but it's not even a standard agile cycles. It more really is like a hyper agile or DevSecOps in some ways. Basically, you'll see and this is what's going on in our company as well, is that you'll see code shipped to production a couple of times a day. So it's not like we have, and I'm not talking about waterfalls where you really deploy once a while, but it's not even going through a full cycle. Everything is automated and code is written and shipped into production a couple of times a day. Processes, as I just mentioned, should mostly be automated. It's kind of hard to do things otherwise because you don't own the infrastructure and you don't own the environment, so your visibility is very limited. It's not for everything you can SSH and run monitors and tails and see what's going on. Everything is monitored, but it's not owned by you, so you have to consume this. And the way to really operate it is to automate everything. So when something goes wrong, you have alerts. Those alerts are configured on services in your cloud, and those alerts will send you a Slack message or whatever, and then you'll have to take a look. And also, of course, the deployment process. This decision-making is very bottom-up. It's not what we were used to maybe before with the monolith app. Developers take the decisions to deploy to production. They take security decisions as well. And we'll talk about some of those challenges in this talk. All right, so how does the serverless architecture look like? This is an example, but this is a very tiny example. It could look a little bit confusing in what's going on in there, but maybe there are a couple of dozens of code resources, which are functions in this case. We've got customers with hundreds of thousands of functions in a single system. And you cannot imagine the sphere of this, how would you even approach this in the security way? And we'll talk about why is it a problem, because actually each of those resources has to have, in some ways, its own security, because they are not really connected in a same environment. Each one of those has to have its own security. Okay, but it's still a Lambda function in this case, which runs our code, and it has a service behind it, like a database, and it has its permissions, which we all know that we need to use, and there's an API gateway in front of it. So this is like a traditional, maybe API call, REST API. So yeah, it's separated into 3 different resources, maybe 4 different resources, but it's the same security, right? So in this case, some of it might be the same. You still have to understand the permissions, how they work in your cloud environment. It's not so easy, and we'll see why. But this is a very, very common case. It's also just one case. What about this? This is another case. There is a code that runs after someone talks to an Alexa device, like an Echo Dot, which runs an AWS service called Alexa Skill, does the same operation, but instead of an API call, a regular API, which we all familiar with, there is a voice, right, command that translates into code. How do you apply security for that? How do you think about the security? Is there, like if it's a REST API, then we all know, yeah, we have the path, and we have the headers, and we have maybe the body, it's a JSON, maybe. How do you approach voice commands? So it's not trivial. It's not that it's not doable. It's just not trivial in some ways. And I showed, this is not a new, it's an old video I did in 2019 about how I'm able, it's a POC of course, how I'm able to steal data from the database using my voice command. Okay, so it's not something that is, again, something that we cannot protect. It's kind of actually easy to protect. We just need to understand that the way into our code is, maybe the attack surface, if we want to call it that, is different. And we need to think about it. Okay, so serverless, taking most of my example from AWS, but we have Azure as well, and we have GCP, and they're getting more and more common. Still, the AWS environment is the most common one. So we have an event that happens in your cloud, and that triggers your code. The Lambda function is a compute service, and it communicates with a service, right? Any cloud service, so it could also be an out-of-bounds service, doesn't really matter. What happens is that when this event happens, and there are some examples here, let's say someone updates the database. Okay, this triggers your code. Triggering your code means that AWS, in this case, or Azure, it doesn't really matter, spins up an environment that runs your code. And when it's finished to run the code, this environment does not longer exist. Well, it does exist, but it's not longer running for you. And this code in the middle is why we are here, because we are still in AppSec, is because this is your code. And your code, of course, means you still have mistakes. So we still have to take care of AppSec inside our serverless environment. Just to understand a little bit more about the runtime, the environment of a Lambda function, it's not exactly the same for all the cloud provider. If you want more information about other cloud providers, well, we can talk later, of course. So the environment is read-only environment. It has your code inside. If you want to write something, you have the /temp folder, which you can write data into it. Again, as I said, the data is temporary because when the code finished to run, then the environment no longer persists. And I put the asterisks there because it does exist for a while. Because if you want to keep some performance, then if you have to create a new environment every time something runs, you lose some time. So basically, AWS recycles environment. And it's a security aspect because if you left something on your /temp environment, it might still be there when someone else, maybe another customer, another user, runs his data. So if you don't take care of the environment, they might unexpectedly land on the same environment, not at the same time, but with the same data inside. The code, as I said, also resides in the environment, which is a security concern. And the keys are the permissions for the code to execute inside the cloud. Is also translated into environment variables, which reside in your cloud. So this talk is about an OWASP Serverless Top 10. Is a project I created. I started a few years ago with an interpretation of the original Top 10. How would the traditional Top 10 would look like in a serverless environment? And we have a still going on open data call that we ask companies that use serverless to contribute so we can create and continue to grow this project. This is the link for the project and for the call. Okay, so the top 10 consists of a couple of course, the top 10 risks. First one would be event injection or the equivalent for an injection attack. Then we have a couple of, maybe the names would sound the same, like broken authentication, sensitive data, overprivileged function, which maybe translate into authorization issues or access control, dependencies. We all know those, and we'll talk about some of them, not all of them. But let's start and understand how is it different. Event injection. Why is it called event injection, or data event injection? Or this is the right now. This is the name that we decided. But again, this is this is an open project, and we're looking for people to contribute. Anyway, event injection, and it's called that way because the code runs based on an event in your cloud, and when the event happens, the data that reaches your code is not fully controlled by you. It's an event data. Okay, I'll give you an example. Even if you send an API, like you have a REST API that goes through an API gateway and it reaches your Lambda function, you don't necessarily have the raw data that was just the raw data that was sent to the API reaching as is into the function. But AWS or the cloud provider wraps it into an event data that contains, of course, other information. An API, of course, is the easiest one. But what if someone uploads a file to a cloud storage? How would that event look like? It's not like the raw data of the file. No, there is an event that tells the function at this time by this user on this bucket for this path. This is the file that someone uploaded or downloaded or deleted. And this event gets into the function, and then you have to decide how to deal with it. Those events might contain input coming from the user in one way or another, and this is basically where we will get the event injection or the input injection that we're concerned about. So you have multiple uncontrolled entry points. Again, you don't own the path between the service and the service that triggers the event and your Lambda. You don't own it means you cannot put a controller in the middle. You can put a controller inside your code, or if the cloud provider allows, on the service itself, but you don't have the network between them. So we still have the same injection attacks, like command injection, SQL, NoSQL, etc., but they might take like a different form. Of course, you have on functions, you have multiple runtimes. You can choose between given ones, like Python, Node are the most common ones. You have Go, .NET, and Java, but you can also run your own, whatever you want, environment. You can create an image with your own runtime inside and run it inside your function. Yeah, the runtime in that case will be owned by you, and also the security will be owned by you, but you can still run multiple runtimes. There are some new type of injection attacks that maybe in a monolith we wouldn't think about it, like MQTT or PubSub injection attacks, that it's not a regular path that we would expect. And the impact for the attack depends very much on the permissions that the function or the code has inside the cloud. It can start from if your function doesn't do anything important in the cloud, just process data and writes logs, then even if someone completely hacks, lands into your runtime and can run code inside, the attacker will still be able just to write logs or read logs, depending on the permission. But if you gave an unnecessary or even necessary risky permission into your cloud, into your function, then if someone has the access to run code or to run data on your runtime, then he can actually land up owning your cloud. And if he has permission to your databases or to your storage or your IAM services, which then controls the permission for all the other services, he can create users, he can change permissions to other stuff, and then can cause more and more damage. So there are multiple entry points into your injection, the traditional injection. The REST APIs are the common one, which we knew before, but there are also third-party application, of course. Cloud storage, we will see an example. Authentication services, logs, events that happens in your cloud. So you can think my code just process logs, right? Analytics. But those logs got from another event that maybe got from another event, and in some path, maybe there was a user input inside. IoT, of course, as I mentioned, Alexa, email, SNS, code pipelines, etc. Everything is given inside the cloud provider. Those services are given to you by your cloud provider to create great apps, which is very cool. But they can still have those their own risks. Okay, let's see that it loads, and we'll see an example of an injection attack. Maybe not a super common. Let's see. Okay, so this is a demo application, which I'll show later. It's called DVSA, and it's a damn vulnerable serverless application, so you can imagine it's vulnerable, right? And in this page, there is a file. I don't know if you have a good resolution here. You can send feedback, and you have an attached file here. The file goes directly into a cloud storage. Okay, so you don't really have given the raw data of the file into your code, but instead it uploads it to a service called S3 bucket in here, and then you get an event, someone uploaded a file. And usually what happens is that you get this event and you get the data out of the event, which file, where it is, and you pull in the data and you assume, okay, I can get the data from the S3 and it's probably where I think it should be, because this is what I given the app to control. And in this case, the file contains a traditional command injection, right? But I'm uploading the file name or the file itself directly to an S3 bucket, which then triggers my code. And in my code, I process the data without assuming that the file name that was, of course, not available, or I did not think about it. The file name itself will have an injection attack in it, even though it's not super uncommon, right? We dealt with files with bad file names. It's just the idea here is that this is an event that comes from a different service and not directly inside your HTTP request or whatever we are used to before. Okay, so I uploaded a command injection, and as you can see, I opened an HTTP tunnel on my computer. It doesn't the internet doesn't go well here. And what I did was I just stole the environment variable. So the injection attack was just running env command. Env command prints your environment variables. Of course, I base64 it. Encoded it so I can send it over the internet, and then I will decode it. And what I'll get there, if we'll get there, Just a second. What I'll get from the environment variables is the key or the keys for the function that the function has. Oh, there it is. Okay. So the function has keys inside the environment variables, and I can steal those keys and use it on my own computer from that point to interact with all the services that these permissions give me access to from my own computer. What the company that developed this application will see is that the function is making API calls into the cloud. Unless they control the IP where the information came from, which I never saw, by the way, on that someone does, because the keys are in their runtime, and the runtime is inside the AWS cloud environment. So you basically don't check the IP because it comes from AWS. So unless you have some alerts coming on, you will never suspect anything, at least for a while. And I'll run AWS command, it's AWS CLI in here, with those keys, with this profile from my own computer, and I can access the service that the Lambda can access. In this case, the A3 bucket. So I can check what buckets are there, or in the cloud. It can be also a different application storage, but they reside on the same AWS account. And I can still look inside, start trying to see what files are in there. I can read files, customer files, data files, and I can even upload files. And this attack, once I have the keys, basically I control the environment for a while now. For a while means for a few hours. There is no like a precision time that AWS publish where the keys will expire, but they will expire after a while, and I'll have to create another request and get another key and recreate those attacks. So the environment doesn't persist for a long time, but I can just redo it over and over. Okay, so what are the best practices? So the best practices will look the same in general. Of course, I will not repeat, but like never trust inputs, don't positive whitelist and everything. But there are two differences. The first one, which we'll talk about more in a few minutes, is the permissions. How you have to control the impact, right? So okay, there might be an attack, there might be a successful attack. Let's control the impact, and we'll talk about it in a few minutes. And the other part of it is that the code must be self-protecting. Okay, why? Because you don't own anything until the data reach your code. Once it reached your code, you basically this is what's going to run, right? So if you don't control the code, if you don't have security controls inside your code, then there are many ways or many occasions where you cannot have other controls at all. For example, you can block the S3 access just to someone from your organization or someone that logged in, but with the right keys, if they have the right keys, they can even access those without. So if you just say, okay, this bucket is secured because only logged user or people from this and that organization can access this bucket, they are the only one that can upload files. So the files that will get to my code will be authenticated, right? Yes, in most cases, but if there is another function that has permissions, wide permission to an S3 bucket, and there is another vulnerability there, I don't know, a CVE or whatever that is, they can still access the bucket. And if they have access to the bucket, they can upload whatever they want, and you'll get unauthenticated data running inside your Lambda function. So you cannot really control, or you should not assume that services that have external interfaces are trusted. I mean, you can at your own risk, of course. In some ways, you have to make some assumptions or prioritize. Of course, you'll get to the directly external facing services, and we'll get to the other one later. Okay, the second part is a broken authentication. Functions, as I mentioned, in some way are stateless. So that means that there are no state in them. They run the code and they die. Okay, and that means that you cannot have inside the Lambda some way to persist a state, because the next request that will come in will be a random runtime. Could be the same one, could not. Also, so you cannot really trust that all the incoming request ones, one after another, will land on the same runtime, and therefore you cannot maintain a state inside your Lambda or your functions. You still have all those multiple entries. Someone sends an email. This email triggers your Lambda function. How do you secure that? There is no like a big flow that will always go through the same path. You will have different runtimes and different environments so you cannot really control the authentication inside your code. This is an example. Like you have someone create a pull request. This triggers Lambda that approves, runs some scans on it, sends an event to the manager to approve, and replies with an email directly to the code, like I approve, and then you can maybe process the code. But if you don't have some limitations in place on the code, maybe someone can just send an email directly to the email service, and it will trigger your Lambda. And in this case, you might end up approving or running bad code, backdoors, for example. So best practices. Of course, use authentication services when they are possible. If your application is fully deployed inside your a single cloud, it's mostly easier because they have supported services. So if you need authentication, they have AWS has Cognito, and of course Azure is even easier. They have AD for Azure and everything that we have already known. When you can, of course, you can use access tokens. So you'll get a JWT, for example, a JWT token reaches your function, and you can verify it with a simple public key. It's quite easy. As I said, we will always in serverless, and specifically in AWS, we will always reach the point where let's protect the impact, okay, with least privilege, because is coming up, it really can change everything in your application. And if you need, you can use an out-of-bound authentication, like you can store state in your database or something like this, just if necessary. Sensitive data exposure, this is like nothing new, but we need to understand where is the risk, where do we have sensitive data. Could be in cloud storage. This is very common. We hear in the news every once in a while, someone leaked a lot of files from your cloud storage buckets that left open, or Azure blobs that contains passports of all the students, because all it needs is to uncheck a box or not to check the right box, and everything is open. There are also tools like, Showdown for IoTs. There are also Showdown for buckets. So you can just search passports. It will look into millions of buckets and blobs in cloud storage, and we'll find you documents. So basically, you have to understand that in your cloud, of course, you have other means that you need to take other means to secure your data. Inside the code or inside the function, the runtime, there are, as I mentioned, a few places. The /temp folder may contain user data. And if you write data into /temp, you cannot assume that it will be automatically deleted. So you need to either encrypt it if it's super sensitive, or delete it just at the end of the runtime. So you make sure there is no data when the environment runs again. The environment variables contains the keys. You cannot have anything to do with that. Sorry. But most of the times when you need other secrets, you'll just put them in the environment variable. It's super easy to use. Just make sure that they are encrypted and they are open in runtime, and you don't put in clear text because it's super easy to steal them. As I said, open buckets is an example, and the source code is also in the environment. So if someone has access to your runtime, they can read your code. If your code has tokens inside or sensitive code, then they can be stolen. Okay, the best practices, as I said, delete the /temp after use encryption services like KMS, which can encrypt both data and keys, whether it's the environment variables or other sensitive keys. You can use other services like secret managers. Of course, everything comes with a cost. Secure your service configuration. Buckets are used, are very common in this case, and list privilege, which we'll talk about in just a sec. And if you're using the cloud a lot, there are also security tools inside your cloud, built-in security tools. So if you run AWS Macy, for example, can scan file sensitive data inside your buckets. Okay, we'll talk about the thing that comes up every time that we talk about serverless is overprivileged functions. We have seen, I think, a couple of hundreds of thousands of functions, if not more. 90% of them are overprivileged. It doesn't mean that they are highly overprivileged, but I think that 95% are overprivileged. That means that the functions has more permissions than they need. Okay, and different from monolith application or even microservices, in this case, you could, if you could, limit every code to the permission that it actually needs. If you imagine it differently, you'd say, this line of code writes to the database, this line of code reads from the database. If I could limit this line of code just to have permission to write and not to read, and this line of code just to read, not to write, when we think about it like this, no, this is crazy. You cannot do this. So with serverless, you can do it. You can say this lambdas are usually very short, unless, again, if you're trying to run microservices inside lambda function, they will be a little bit bigger. But if you write it correctly, then few lines of code, you can assign permission just to what they need to do. So the impact could really be limited to just what's needed. And it's really possible with serverless. It wasn't possible before. As I said, if you give permissions, unwanted permissions, it can lead to data leak, but it can also lead into a full account takeover in some cases. Let's see an example. Very small function that reads data and puts the data inside a table. Okay, what we have here is the original permissions, and what we see from customers is that this happens quite a lot. I'll say around 40-50 of the percent of the function has those type of permissions. It's easier, it works. We have not, customers do not have the time or resources to apply permission to each function, but they do it on microservices. So this permission will apply to a group of functions and not just one. So we end up doing this. And what is this? This means that, yeah, there is an API call here, like an SDK call, however you want to call it, put item, which writes an entry into a database. But the permission assigned to the function is DynamoDB, which is the service, is a NoSQL database with a star after it. The star means anything. The function can do anything inside the service. Not only that, I have the resource also ends with a /wildcard, which means not only the function can do any action on this service, but it can do it on any resource in this service. So any database, could be databases that are not related to this function at all. But the code do it for an hard-coded, you can see a line before, os.environ orders table. So the code is actually just writing one entry into a specific table, but the function could do other stuff. What should happen here is that I should know that if I just do this put item here, I should change the permission to a DynamoDB put item and not wildcard. And the resource should be a specific resource and not any resource. And in this case, even if someone has permission to the runtime and they can even run code, they are very limited. Okay, it's not that it's not a problem. It's still a problem if they can write data into your database, but it's much different than deleting your entire database. Okay, so this is how it works. The problem is, yeah, this is 20 lines of code on one function. What happens if I have couple of 100,000 or a few thousand functions? What happens if it changes every day? How do you control this? The developers will not have time. In many cases, it's not that easy to understand what is the right permissions, right? Could be loading libraries. The libraries do the database entry behind them, the database processing or whatever service that is. So you don't even always know what your code needs to be doing. And it's really not easy to do it manually, especially if you say, no, okay, the security team will take care of that, right? No, of course not. You have one security person over 10 developers. They ship into production multiple times a day. How can you even think about assigning it to a security person when it doesn't know the code? So that's crazy. So what you should do is you should some way automate it, but you should automate it both in code and both in process. Like you should have a code review or something like this that inside your, your code pipeline, deployment pipeline, to understand what permissions are needed. Maybe a security team will review, but you cannot expect a security person to know what the code should do and assign you a permission. It's really impossible. And we've seen customers trying to do that. It doesn't work. The other way to automate it is with tools. AWS provides some tooling for after the fact. They can tell you, okay, this code in the last 1 month ran this API calls. It's good because you know what it ran, what actually ran, but it doesn't really tell you what could run or what should have run, because maybe the next day the code will change, or maybe there is an exception that didn't happen yet, and in this exception you write into a different log, so you don't really, but it helps. There are other ways to do it. Again, the video will not load here. So the other way to do it is with CodeSec, and I'm showing it here because it's an open source project. Okay, you can run it. You can give it a Lambda function. It will scan your code based on the code itself. Yes, including libraries. Based on the code itself, we'll see the path. It will see the path that the code could go to, and will give you a copy-paste version of the policies that you need to assign to a function. So you can have this, for example, as part of your process, where every time you deploy a new code, it runs on your code and it gives you the policy. Let's see if it runs. It gives you the policy that you need to assign to a function. Wait, it was a picture of a black screen. And it takes less than a minute, really. A few seconds. It runs on your code and will give you the policy. Unfortunately, oh, there it is. All right, so I have here a list of function. I chose one. I ran the command. It's really 3 commands. You cannot see. Is CodeSec function. You get your functions. You get the functions, and then just CodeSec scan, serverless scan, and you get the policy. There it is. Let me stop here. So you get the policy as a JSON, or you can also have it as a YAML, whatever you work with, and you can theoretically copy it and paste it into your infrastructure as code or into your cloud. Of course, in some cases you will have to change if you're putting it into your infrastructure as code, you'll have to change the hard-coded values like the account ID into an account ID variable, but that's mainly it. And it's open source, so you can download it and use it. Okay, starting to wrap up. Okay, so vulnerable dependencies, there is nothing new here, but many times Lambdas will do just a small line, like a few lines of code, custom code, but in order to support that custom code, that will bring with them a lot of dependencies. Some of the dependencies will be built into the runtime. If it's an cloud provided runtime that it owned by the cloud provider, also the security of it will be owned. It doesn't mean that you will not have CVEs inside your runtime, but if there is a CVE, they should take care of it. No, it should. Okay, you can run with it or not, but they will take care of it eventually. But you also import your own libraries into your code, so just understand there is a risk. Again, if you run CodeSec, you can also get CVEs in your Lambda functions. Same scan, you'll get them together. This is an example of log4shell. If you will remember inside the Lambda function, so you can say, okay, but functions doesn't have the same as maybe a log4j. They do. And log4j is not uncommon in Lambda function. So you can still have the same vulnerabilities that can still exploit your keys, and we already saw what you can do with your keys, with those keys. Third-party best practices, again, scan your dependencies. You should scan them before in your repo. Is the best place to get, is the earliest place to get it. Not necessarily the best way to get location to get it, because you get a lot, and in some cases you have filters, and you have in some cases you have other services that helps you deploy your cloud environment, like infra as code. So for example, if you're using serverless framework, not serverless, the term serverless framework, they stole the name. It's an infrastructure as code. In order for serverless framework to deploy a bunch of stuff into your cloud, they need their own permissions, and they need their own code, and they need their own libraries. So they'll push libraries into into some of your code, and you'll say, "But I scanned it on the repo. How do I have those permissions, or how do I have those libraries in my code in production?" It gets there. So you can also have scan your CVEs inside your production or your pre-production or whatever the environment that is. Logging and monitoring, I said the problem here is that there is no, but it's not owned by you. You need to consume it from your cloud provider, and they have services that have logging mechanisms. You just need to create automation around them to get the right alerts, to write notifications, to get the right errors. No one will tell you there was an error. You'll not see something different. You'll just wait, nothing happened, and then you'll have to start looking and picking up into logs, and it's not an easy task, believe me. So you should create alerts that gives you those, let's search for strings inside log entries, and when I get those errors, maybe a few times in a period of time, then maybe send me an alert. It's not an easy task, by the way. And so manually, it's easy when you have a few functions, but if you have millions of invocations, it's really hard to manualize it, to do it manually. All right, I'm summing up. So we talked about event injection, authentication, the data exposure, overprivileged function dependencies, and logging. There are some other stuff which I will not cover now, but you can go into the project and read about them, like open resources, denial of wallet versus denial of service, insecure shared space. We talked a little bit about the /temp folder, insecure secret management, etc. Okay, last thing I'm going to talk is another project. I don't have this talk also, but if you're interested, there is a project called DVSA, Damn Vulnerable Serverless Application, where you can, with 3 clicks, or if you like CLI also, deploy it into your cloud. It works out of the box. You have all the vulnerable code, and you have documentations of the vulnerabilities and how to hack them and how to fix them. Some of them, not everything is documented. And as I said, it's open source. You're more than welcome to contribute. I would love people to contribute to that. and works just on AWS. And maybe the most important part of it is that please do not deploy it on your AWS where you have sensitive data, because as I said, if one function is vulnerable and has permission to a service, it doesn't really matter if it's parts of an application that you have or not. It can just access this service and steal all your data. So basically, if you deploy this on an AWS account, this account is open, okay? So don't deploy it on AWS accounts where you have sensitive data in it. That's it. Thank you very much for coming and joining today.